To say I'm intrigued of how we're going to get electrical science and principles lesson out of this Scalextric, Chris, would be a massive understatement. But you're the man. If anyone can, Christopher can. So what we're going to look at first, this little car down here.
Taking the top off the yellow car, and what we can see is we can actually see the little DC motor itself and the gearing. And I do this usually just to show students how one turning motion can actually go in a different direction and turn the actual wheels. Obviously, when it's powered up, we'll see that the vehicle will actually move this way. So if the motor is actually turning, it's actually putting the force onto the wheels.
You said it's a DC motor. We've got a battery pack here, so normally their mains connected, but this one is battery powered. So it's a DC motor, but it's only going to be going in one direction, aren't we? So these haven't got the ability to reverse the motor, have we?
I haven't got the ability to reverse the motor on these, to be honest.
You spent a whole £5 on this.
I have. I thought it was ripped off, Gaz, at £5.
Now, we talk about a motor having brushes. We can't obviously see the motors within the brush, but because it's a Scalextric, when we turn it over, we often call these brushes, don't we, on the actual car itself. But they're actually just picking up that DC current, aren't they, off the track itself?
Yeah, they're picking the DC current up off the supply, off the actual track itself. So these are the pickups, but yeah, we do call them the brushes. This is just a guide to keep it in within the track, and then the brushes go on to the positive and negative. I need to change the wiring system inside here to change the polarity to make them go the other way. But when we have a race, I don't want to be going in reverse, Gaz.
No, you don't, and that's something we are going to do. So what do the learners get out of this, apart from some incredible fun times whipping around the track? I see you've altered the controllers to be more student friendly. There's a little block on there so we can't go too fast. So what are you hoping that they remember from this experiment?
So what we actually do with this is a rheostat. We can explain that as being a variable resistor. Yeah. What we can do is we can use Ohm's law, and we can say if we actually have the voltage that's going to be staying as 4.5 volts as it is here, the resistance or the inductance of the motor will stay the same. However, if we add extra resistance here to the circuit, the current flow will change. So if the current flow changes, therefore the speed of the motor will change.
And therefore make it that little bit faster.
So therefore it'll make it fast and slow. And we can obviously introduce back into Ohm's law. And also we can talk about the DC motor within a cordless drill, as well as in this practice as well here. Obviously on a cordless drill we have the reversing switch like we mentioned previously, but in this situation I've got to change it here.
And that's a good one to link into, and it when so many tools now on site are battery powered, and obviously in colleges as well, that is a DC motor and has the ability to change it. Unlike this one, I do like this. You need to get your car back together, because I'm going to take the red one. So we're both wearing red today, and thank you very much for this series of videos as well, Chris, to see who is the fastest round this extensive little track. Oh, my fault. Oh, count as a false start.
Oh, you look at that driving. What more can I say?
Ah, it's just unbelievable. Look at that. You're going to lap me. Shorter one, inside short.
Look at that. Oh, another one!
And anyone knows me, I know I'm useless at driving. However, if you want to check out the eFix website, we have an apprentice hub page on there where you can have access to about 1,000 multi-choice questions, some electrical handouts for tutors and for learners, and some other great resources where also the playlist on Science and Principles will appear, as well as on YouTube. Thank you very much, Chris.
Not a problem, guys.
Look,
enjoyed it again.
No.
I'm a lap in front of you, mate.
No.
A lap in front of you.
It's a fix.
It's an e-fix.